I have already run this. It takes a bit of time to run, but I'll be explaining how we can use this using TensorFlow and so on. So what we do is first, TensorFlow is a package that has been developed open source for deep learning, and it has very good implementations of all of the networks we will be seeing in this course apart from RNNs. So what we do is you just start with the importing, you import the library for plot as well. So in this particular task, what we're going to do is take the IMDb movie reviews, and it's a binary classification data set where all reviews either have a positive or negative sentiment. And it comes with the TensorFlow package itself, and it also very conveniently comes with the training set and the test set. So you download that. First, I should tell you what is a tensor. Tensor is basically metrics of matrices. So a vector is like a single dimensional thing. A matrix is a two-dimensional again thing. But a tensor is like a matrix of matrices. And if you see how the text is, it goes like this. This was a terrible movie, blah, 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 blah. And the label is 0. So label is going to be either 0 or 1. Okay. And yeah, these are some hyperparameters, as you could call it. And then we do some basically we see how the text is, which is basically review, and then you have the labels, and you're changing it into a vector basically in this step. So this is all the pre-processing. You take the text, it's first in just a sentence, and then you change it to lowercase, you make it more convenient for the machine to read, and you make it into a vector. So you have your input text and your output text. Of course, from this input of characters and text, we need to move to a vectorial and a high dimensional space. So you will be this is what we call as a text encoder. So what do we do for that? You can specify the vocabulary size, or it will choose its own vocabulary. We do this so that you can save on time, but what that will imply is that some of your words will become like unknown. We'll be seeing some examples. So if you specify that my vocabulary has to be of this size alone, it will just take the top 1,000 words in your data set. So but of course, the interesting thing is all the other words will be mapped into this unknown category. So your encoder's vocabulary will be set, and it's adapted to this particular data set. And we have this vocabulary. Now, when you take the example, so what does this mean? So the zeros talk about the padding I was talking to you about, which you have a sentence, and these are the indices of the words in your vocabulary. So 590 means in my vocabulary, the 590th word. So finally, this is what it will look like. It will be replaced by the unknown whenever your vocabulary is failing. This is how we are going to create the model. And this is where our text embedding is also going to come into play. So our initial input is that was a great movie. It is now changed into this vector of positions based on the vocabulary. So this implies that that is the 5th word in our vocabulary that has been built for us. And we have this sequence of words in the vocabulary. Now we will have another lookup, which is going to be for the fifth word, what is the embedding? And here, that's why it's called E of 5. Now here the embedding, you can do two things. One is you can train the embedding, so the weights in this are also going to be trained. Or you could use the pre-trained vectors we saw in the last class and upload your word to vec, your glove vectors, and so on. So it depends on your application. If you have huge data in terms of 100,000 and so on, then you can learn the embedding for your data set. However, if you have a very small data set, even something to the range of 1,000, then it is advisable to use pre-trained data sets and use your and not learn the weights of this network. You're basically going to do a lookup and not allow anything to happen here in this section. Also, in your neural net starts from here. So this is your input and this is the input. This is the layer. If you are going to use pre-trained vectors, your neural net is going to start from here. So in this particular example, they have used the bidirectional RNN. They're using a variant of RNN known as LSTMs in this network, which we will see next class. And then we have something known as a dense layer. A dense layer is basically in our multi-layer perceptron, we say fully connected, where every node in the previous layer is connected to every node in the next layer. And that will give us one output, which is going to lead us to classification. So this is our setup for the neural network. And we'll see in TensorFlow and Keras how easy and intuitive it has been implemented. So this is known as a sequential model because it's in a sequence of layers. And the first is the encoder, which converts, this is the encoder layer, and this is the embedding layer, and this is your actual RNN layer. Okay, so in your sequential, you add this encoder and embedding and bidirectional. And so bidirectional LSTM, you can use RNN, but you will see the exploding and vanishing gradients. And then you have the dense and again a dense. So this is basically to reduce the input, and finally you collect all of them together into one output node. Okay, so this is one way of doing it. Another way is you simply put model equal to sequential and then model dot add embedding model dot add bidirectional. So you'll see it's very intuitive to use. Once you have this picture and you decide how your network is going to be, you just keep adding those layers to your model. So masking is one way. If you don't use padding, you can use masking. It's both the same, and it's taken care of by default. Here they have explicitly mentioned that few inputs are masked, and they're doing an analysis on that. So here is where you finally come to the training. Epoch is how many iterations you're going to train. And if you give the validation data as the test data itself, then you're basically done. But in reality, what you do is you will not have access to your test data. So you will have your training data. In the training data, you split into training and validation. And whatever model you get, that is what you test on test data. It is not good practice to model on your test data directly, because that's like cheating. Yeah, not totally, because it is not used while training anyway. So let's see. So I'll just run this to show you. Oh, I can't do that. Okay. Fine. And there's one more place where I have trained this. So basically what will happen is while it is training, this will get keep getting filled, how much time it takes, and so on. The thing to note, of course, is that your loss and accuracy will keep getting better. So accuracy increases and your loss decreases. That is the idea we are looking at. And you can run it for more epochs and so on and so forth. So what are we doing here? We are finding out with the number of epochs how our accuracy increases. Actually here, if you see, within 2 epochs or 3 epochs itself, we get what could be our maximum value. With the other data sets, so again, epochs is a hyperparameter. You have to figure out how it is changing over time. And I will be releasing the assignment this week where you need to include these plots and describe why you chose hyperparameters or why you chose a particular value. Similarly, the loss has to decrease. Accuracy increases, your sentiment analysis increases, and your loss decreases. You can use this assignment as a guideline for how your report should be. So all this is fine. At the end of the day, you need to predict the sentiment, right? So given this text and you give this prediction, if you output and see, you'll get a value, and how it will be a real value. You're not going to get 0 or 1, but we'll take it as if it is positive, then it is positive, otherwise it's negative. So you can run that and see. Now the interesting thing is you can use RNN after RNN. So it's called stacking. And that's going to give you a more complex model, and you'll see that the accuracy actually improves. You have terms like Adam optimizer, binary cross entropy. So here, these are things you do to improve your performance, and you use entropy for accuracy. So with these, perhaps I can ask a poll or something later in the course whether you'd like me to take these kind of nuances in deep learning. So this is common for all deep learning models. So since this was not focusing on the NLP part, I did not initially think of putting it part of the course, but you can let me know. So then you can, instead of course, predicting on one particular value, you can run it on the data set, and you will be able to see what is the accuracy, and it turns out to be 86%. And yeah, this is for the new thing where we have stacks of layers, and it's quite similar. Your plots are going to be very similar. It's just the number might change. You might need more epochs or less epochs, and so on. So yeah, today I'm done. You have any questions, and you have placement after this, you can, yeah.
One question.
Yeah, tell me. I can't hear you, Ayush. Would you please do something? I don't know. Is it just me or other people able to hear? Okay, just
No, ma'am. It's not very clear for me too.
okay, okay. Yeah, tell me.
Model. We
You
just
had a question?
mentioned that. Can you hear?
Yeah, tell me.
By defining a model, we just mentioned that this RNN, some LSTM, in brackets we give 64 value.
Correct.
Like how does the model define the connections, ma'am? Like how does it do it by itself?
Okay, that is taken care of inside the TensorFlow network. So if you see the code, so everything is open source. You can look at the TensorFlow code in LSTM. So when I say LSTM of 64, what it will do is create 64 nodes, which is, and there was also a bidirectional path, right? So there will be connections in the forward direction and the backward direction. And when you train it, the weights are updated just like how we saw in class today. So all of this is done in the function. by TensorFlow and Keras. So Keras is basically giving you this neat approach where it says LSTM of 64, and your TensorFlow actually gives you things that okay. How do you compute error? How do you compute different gradients and so on? So yeah, I'll just share the. So you remember the picture I had shown, right, where you had the encoding, embedding.
Yes, ma'am.
So
Yes, ma'am.
the weights are connected that way, from the encoding to the embedding to the LSTM value. So all of that is taken care by TensorFlow, and you can have a look at the code to be convinced. The tricky part is, of course, knowing what number to use: 64, 128, 100, 200. It's totally up to you, and with data, you'll learn that. I hope I answered the question. So for the assignment, I'm planning. Actually, I thought of releasing the assignment today. What happened was there were some problems with the data set. So basically, I will be hosting it on Kaggle, where you will not have access to the test data set, only the training, and it will be a sequence to sequence model, which we will see next week. But I'd suggest you run this network at least one sequence. You'll know how to model, so that when we come to sequence, it becomes easier. And the task is, you have a math word problem given. That's the input sequence, and your output sequence is an equation. How you will deal with that is what we're going to see. One thing you have to remember, that RNN is used to model one sequence. So that's why we'll be seeing what sequence next class. Before we leave and disperse, I'd like you to think, what other sequences do you think are interesting for computer scientists apart from language?
Do audio samples count as sequences?
Yeah, audio samples is a good idea, because you have across time. If you can find an embedding, yes, that's a good one. Any other ideas? Anything across time, I can think. Okay, mostly they are used for. Oh yeah, anyone? Someone unmuted?
Ma'am,
Yeah.
mathematical equations or
Yeah,
like
that's okay. Like that's anyway text, right? From text to text. I'm talking about things that are not text. Another thing that they are majorly used is videos, video information. And then one of the other ways is, of course, what we call as time series data. The sales you predict over a period of time, or the shares you predict over a period of time. So it's actually something, this simple idea actually is being used for a lot of applications in computer science that are very commercial. So you'll be, once you learn this particular technique, you can apply it for different things.